Our today's topic is simple harmonic motion. Let's see what is simple harmonic motion. Okay. Simple harmonic motion is a periodic motion. For a periodic motion to be simple harmonic, it should satisfy two general conditions. The acceleration of a body should be proportional to the distance of the body from mean position, and second criteria is the acceleration of the body should be directed towards the mean position. Pendulumത്തിന്റെ കേസ് എടുത്തു കഴിഞ്ഞാൽ നമുക്കറിയാം, this is a pendulum. Okay, and this is our mean position. Okay, according to first condition, we have acceleration. Acceleration should be proportional to distance of the body from mean position. Let this be distance of the body from mean position. Okay. Then second condition is the acceleration of the body should be directed towards the mean position. So acceleration of body should direct towards mean position. So these are the two conditions for a periodic motion to be simple harmonic motion. First example is motion of pendulum. Second one is motion of body attached to elastic spring. Now let's derive equation of simple harmonic motion. Okay. We can model simple harmonic motion as a projection of particle rotating at a constant angular velocity omega, rotating about a point O with a radius r equal to the amplitude. Okay. And let theta equal to omega t. Okay. Here you can see the diagram. So let's consider position of the particle. Let this be a position of particle. Okay. At this position, projection of particle to the y-axis is P, point P. Okay. Point P you can see here. This is the projection of point M towards vertical axis. That is point P. Okay. Let's consider the particle is initially at this point. This point corresponds to mean position, and as it reaches M, it will be having some displacement. Let that displacement be represented by the projection to the vertical axis, that is y. As the particle reaches point M, the angle traced by the particle is omega t. We know theta, relation between theta and omega t. We know omega is equal to theta by t. Angular velocity equal to angular displacement by time. So we will be getting theta as theta equal to omega t. So omega t is nothing but theta. Okay. So we will be getting this relation at this position. Value of theta is omega t. First of all, we have to determine expression for velocity and expression for acceleration. Then we can determine what is the maximum value of velocity and what maximum value of acceleration. In the last slide we have seen y is the displacement. This is actually for projection of point P, projection of point M. Projection of point M is T. Okay. So what is y? Y here is OP. Y here is OP. Okay, what is OP? We can determine OP from the trigonometric relation r equal to sin theta. Okay, what is sin theta here? Sin theta or sin omega t. Sin omega t considering triangle MPO. Sin omega t is opposite side by hypotenuse, that is y by r. Okay, so we will be getting y as r into sin omega t. Clear? So we have got expression for y. Y is nothing but displacement. We have got expression for displacement. From the expression of displacement we can determine expression of velocity by differentiating with respect to time. Square theta equal to 1 minus sin square theta. We are applying this relation here. So cos omega t will be equal to root of 1 minus sin square omega t. But we know what is sin omega. Sin omega t is, from this relation we have Sin omega t is sin omega t equal to y by r. We are substituting that value here. Okay. Now you can take LCM and take the root r square in denominator outside. Okay. And it will get cancelled. Then we will be getting expression for velocity as v equal to omega root r square minus y square. Once we get value for velocity, our next attempt is to determine the maximum value of velocity. Okay, velocity will be maximum. Consider this expression. This will be maximum. We will be getting maximum value for velocity at y equal to 0. We will be having maximum velocity at y equal to 0. So substituting in this relation, v max equal to omega root r square minus 0. Okay, which is nothing but r omega. This is how we are getting maximum velocity. Similarly, our next attempt is to determine expression for acceleration. We have this value. This value is nothing but expression for velocity. We are once again differentiating this expression. So we will be getting d square y by dt square. Okay. When we differentiate cos omega t, we will be getting minus sin omega t. So a minus sign will come here. Minus sin omega t. So we will be getting also a omega will come. So minus r omega square sin omega t. That is a equal to minus omega square y square. Omega square y. This is the expression for acceleration. In order to get maximum acceleration, we have to substitute y equal to r. Mass will be at y equal to r. That is our displacement. Y tends to radius or amplitude. R is nothing but amplitude or maximum displacement. Okay, we will be getting expression for maximum acceleration at y equal to r. So maximum acceleration will be equal to minus omega square into r. Motion. First one is amplitude. We know amplitude is the distance between extreme and mean position of the particle executing SHM, and it is the maximum displacement. That is the important point. It is the maximum displacement of the particle from the mean position. Time period is the time for one oscillation. It is denoted by Tp. Okay. So what is amplitude? Amplitude is the maximum displacement. Okay, if amplitude is the maximum value of y. So we are generally representing amplitude as r. R is the notation for amplitude. And what is time period? Time period is time required to complete one entire cycle. Here either we are represented by the letter small t. In some textbook you can see small t. In some other textbook you can see capital T. In some other textbook TP. All these are the notations for time period. Okay. What is the relationship between omega and time period? Omega, time period and frequency. Let's see those relations. We can represent time period or Tp. Okay, let's consider time period as Tp here. So what is Tp? Tp equal to 1 by f. F is the frequency. Okay. Similarly, we can relate time period and frequency with angular velocity by this relation omega equal to 2 pi into f, which is equal to 2 pi by Tp, and time period Tp is 2 pi by omega. These are important relations which we are going to use to solve different problems. Simple pendulum consists of a bow, which you can see in the diagram. This is bow. Okay, this bow is executing simple harmonic motion, and this is our mean position. Let L be the length of the pendulum, and let mass be the let m be the mass, and theta is the angular displacement. This is angular displacement. Let linear displacement of bob be. Let linear displacement of bob be s, as you can see here. This is linear displacement from maximum position to mean position. We have the relationship between linear motion and or linear displacement and angular displacement. We know angle equal to arc by arc length is here s, by radius is l. So you can relate s, arc length is approximately equal to the linear displacement. So s will be equal to l into theta when theta is having very small value. Okay, so this is what written here. Now we have expression for time period. Time period is in some textbook, time period is represented by tau. Everything is same. Tau or t or tp or capital T. All these are notations for time period, which is equal to, as you can see here, 2 pi by omega or omega n, which corresponds to natural frequency. So we will be getting 2 pi root m by k. This relation you have studied when you learn about the motion of a spring mass system. Okay, so 2 pi root m by k. This is one relation. And another relation pertaining to simple harmonic motion of a simple pendulum is this one. This is very important relation for relating angular velocity and acceleration due to gravity. Okay, and we have studied omega is equal to 2 pi into fn. That is frequency or natural frequency. 2 pi fn equal to root g by l. So we will be getting expression for frequency as 1 by 2 pi root g by l. We know Tp equal to 1 by Fn, so we will be getting Tps, which is equal to 2 pi into root L by g. Okay, this is the expression for time period in the case of simple pendulum. A body is vibrating with simple harmonic motion of amplitude 100 mm and frequency 2 vibrations per second. Calculate the maximum velocity and acceleration. Amplitude. Amplitude is represented by letter R. R equal to 100 mm, which is equal to 0.1 meter. Okay. Frequency of body, or what is frequency here is 2 vibrations per second. We can represent frequency by the letter F, which is equal to 2 vibrations per second. Now we have to determine maximum velocity to find. We have to find maximum velocity, that is V max. Also, we need to determine maximum acceleration, which is represented by A max. Okay. Now, what to find out first? We have to determine angular velocity. In order to determine maximum acceleration and maximum velocity, we need to find out what is angular velocity. Okay. We need to determine angular velocity. So, what is the expression for omega? Omega is equal to, we know omega equal to 2 pi f, 2 into pi into f, f is nothing but 2. So we will be getting 4 pi radian per second, 4 pi radian per second. This is our omega. Okay, now we can determine what is maximum velocity. Maximum velocity equal to r omega. R into omega. Substitute the values. R is 0.1. Omega is 4 pi. So we will be getting value as 1.257 meter per second. Okay. This is maximum velocity. Now we have to determine maximum acceleration. Maximum acceleration equal to r square omega, or omega square into r. Omega square into r. Substituting the values, we have omega equal to 4 pi square, where is R value, R is 0.1. Substituting the value, we will be getting 15.79 meter per second square. The piston of a steam engine moves with simple harmonic motion. The crank rotates at 120 rpm and the stroke length is 2 meters. Find the velocity and acceleration of the piston when it is at a distance of 0.75 meter from the center. Given frequency of the piston, frequency on n equal to 120 rpm, stroke length L equal to 2 meter. Find the velocity and acceleration of the piston. Okay, we have to find out velocity and acceleration of piston at y equal to, at a distance 0.75 meter. Okay, to find V and A. Okay, for this we need to determine angular velocity first, as we did in last case. What is the relationship connecting omega and n? Omega equal to 2 pi n by 60. Okay, substitute the values. We have 2 pi into, what is n? N is 120. N is 120 by 60, which will be equal to the value of 5. 2 pi n by 60 ചെയ്യുമ്പോൾ എത്ര വരും? 4 pi. What is the expression for velocity? Velocity, last problem maximum velocity ആയിരുന്നു. ഇവിടെ velocity at y equal to 0.75 ആണ് നമുക്ക് വേണ്ടത്, 75 meter. So expression for velocity is omega root r square minus y square. Okay, substitute the values. It is equal to 4 pi root. What is our value? Our value is 1 square minus y square. Y square is 0.75 square. 8.3. Okay, 8.3 meter per second. Now find out acceleration. Acceleration relation എന്തായിരുന്നു? Omega square into y. Substitute omega value 4 pi ആണ്. 4 pi square into, what is y value? Y value is 0.75. What is the value?
118.31.
118.31. We can write 118.43. Okay, 43 meter per second square.